storage systems are inevitable for modern-day computing. All known computing platforms ranging from handheld devices to large supercomputers use storage systems for storing data temporarily or permanently. Beginning from punch card, which stores a few bytes of data, storage systems have reached to multi-terabytes of capacities and comparatively less space and power consumption. This video is intended to give an introduction to storage systems and its components. Storage is the place where data is held in an electromagnetic or optical form for access by a computer processor. In a more formal usage, storage has been divided into 1. Primary storage, which holds data in memory, sometimes called random access memory or RAM, and other, built-in devices such as the processor's L1 cache, and 2. Secondary storage, which holds data on hard disks, tapes, and other devices requiring input or output operations. Now let us talk about few classifications of memory devices such as primary and secondary and tertiary storage, volatile and non-volatile storage, read-only and writable storage, random access and sequential access storage, magnetic storage, optical storage. 7. Semiconductor storage. Let us see in detail about each type of storage devices. 1. Primary and secondary and tertiary storage. In simple words, primary storage is the storage device that is directly connected to the CPU and store data temporarily during execution. That is, CPU can directly access primary storage and stores instruction and data for execution or processing. The most popular example of this kind of memory is the random access memory that we use in modern-day computers. CPU registers, caches and other memories connected to the CPU local bus falls in this category. Primary storage devices are comparatively faster than all other kinds of memory types. Usually primary storage devices are considered to be directly connected to the processor. But in reality, modern computers employ components like virtual memory manager, DRAM controllers, etc. in between processor and the memory, but the notion of direct connection is still valid since these components are transparent to the processor. Volatile memories are usually used as primary storage. On the contrary, secondary storage may not be directly accessible by the processor, and is usually used for more permanent storage of data. This requires secondary storage devices to be non-volatile. Secondary storage devices are connected to storage controllers and the CPU is required to talk to the controllers in order to access information from secondary devices. The most popular example of secondary device is the hard disk. CD-ROM, DVD-ROM, USB mass storage devices, floppy etc. are also falls in this category. Secondary storage devices are also called mass storage devices since the capacity of these devices are comparatively large. In contrast to primary and secondary storage, tertiary storage may not be directly connected to the CPU or the computer itself. Tertiary storage mechanisms usually used for storage of large volume of data such as backups, etc. A commonly used mechanism for tertiary storage involves a large number of removable mass storage devices stacked as a library, and a robotic arm picks up the required media and loads into a media reader. Once the required information is read, the media is placed back in the library. The mechanical delays associated with tertiary storage makes it the slowest of all storage types but largest in capacity. 2. Volatile and non-volatile storage. As the name implies, volatile memory loses its contents when power supply is withdrawn. So usually volatile memories are used for temporary storage of data. In some exceptional cases, Volatile memory devices are used along with long-life batteries to make semi-permanent storage devices. Compared with non-volatile storage, volatile storage devices are faster while both reading and writing data. This makes these kinds of memories very suitable to be used as main memories of computers. In fact, the memories we use in computers, RAM, are volatile devices. Non-volatile storage devices retain the contents even in absence of active power source. This makes non-volatile devices suitable for long-term permanent data storage. Non-volatile devices usually available in large capacities. Hard disks, CD-ROM, floppy disks, flash, ROM etc. are examples of non-volatile memory devices. Non-volatile storage devices are slower when compared to volatile storage devices. But some non-volatile can faster during read operation and slower during write operation. Semiconductor non-volatile memory devices fall in this category. 3. Read-only and writable storage. Read-only storage devices only allows contents to be read from and doesn't allow the contents to be modified. Meanwhile, writable storage devices allow both content retrieval as well as content modification. Read-only devices are usually used for long-term permanent storage where modification of data is not necessary. CD-ROM, DVD etc. are examples of read-only storage devices. Some read-only storage devices comes with factory-programmed data which you can only read but not modify. There is another class of devices called write-once read multiple, worm devices which allows us to write data to it one and only one time and allows any number of subsequent reads. CDR and DVD-R technically comes under this category. 4. Random access and sequential access storage. Random access storage devices allow retrieval of content from any location in the same amount of time. That is, latency is independent of content's location. RAM used in computers is an example of random access memory. In sequential access storage devices, data can be accessed in sequential manner only, and the time taken to read from a particular location will be dependent on the location last accessed. Example of a sequential access device is the tape storage device. Sequential access devices are usually used for backup purpose only, where frequent access of information is not required. 5. Magnetic storage. Magnetic storage devices store information in the form of magnetic field on magnetically coated surface. Magnetic storage devices fall in a category of non-volatile devices. This makes magnetic storage devices to be useful for long-term data storage. Hard disks, floppy disks and tape devices are examples of magnetic storage devices. Data is written to magnetic media with the help of electromagnetic heads. The same head is usually used also for retrieval of data. Though magnetic storage medias can hold large amount of data, these are considered to be bulky and not usable for mobile applications. But technological advancements made it possible to create large-capacity magnetic storage devices with small size. An example for this is Apple's iPod Classic, which is available with a built-in hard disk with a capacity as large as 160 GB for music or video storage. 6. Optical storage. Optical storage devices store data on reflective polycarbonate discs in the form of pits and bumps. Data is recorded on the disc by pointing modulated laser beam onto the rotating disc. This makes a series of tiny pits which doesn't reflect light and bumps that reflect light. For reading the data, a low-power laser beam is focused to the track and the reflected beam is directed to a photodiode. The photodiode detects the presence of pits and bumps from the reflected laser beam and converts it into bits and bytes of information. 7. Semiconductor storage. Semiconductor storage devices store data in tiny memory cells made of very small transistors and capacitors made of semiconductor materials such as silicon. Each cell can hold one bit of information and an array of cells stores large chunk of information. Semiconductor storage devices can be volatile and non-volatile. RAM is an example of volatile semiconductor storage device. EEPROM and flash are examples of non-volatile semiconductor storage devices. Flash devices are gaining popularity over conventional secondary storage devices like hard disks. There are a large number of products in the market now which uses flash devices exclusively as secondary storage, for example, MP3 players, mobile phones, etc.